Bismillahirrahmanirrahim. Still, we are discussing how to solve the quadratic equations, and this is the second part of the last method, which is the quadratic formula. As we mentioned before, that the quadratic equation can be solved by using different methods or techniques, and one of them is the quadratic formula, which is given by x equal to minus b plus or minus b square minus 4ac divided by 2a, given that the quadratic equation, which is ax squared plus bx plus c, is in the standard form. Standard form means the right-hand side equal to 0 and everything is in the left-hand side. And last time we mentioned something about the discriminant, and we said that the number and the type of the solutions is determined by the discriminant. Discriminant, it is this part, b squared minus 4ac, what is inside the square root. b squared minus 4ac has three cases. Either it is greater than 0, in which we are going to have two distinct real solutions, and this was discussed in the last part, or the discriminant b squared minus 4ac equal to 0, and this will give me one real solution, and that solution is double solution. Or if the discriminant is less than 0, I will have a negative number. Then the quadratic equation will have two distinct non-real or two complex solutions. And we said that this solution will be conjugate. By the conjugate, I mean that if the first one is a plus bi, the second one will be a minus bi. These are conjugate. Now let's discuss this with more examples to explain or to clarify this idea now more. In this example, I need to solve the quadratic equation using the quadratic formula x squared plus 6x plus 30. This equation is in the standard form. So a equal to 1, it is the coefficient of x squared, b equal to 6, and c is the constant, it's 13. Now the quadratic formula is x equal to minus b plus or minus square root of b square minus 4a c divided by 2a, which is equal to, it is minus 6 plus or minus square root of 6 square, it is b square, which is 6 square, minus 4 multiplied by a multiplied by c divided by 2 times a. This is equal to minus 6 plus or minus square root of 36 minus 52 divided by 2. That will be minus 6 plus or minus square root of minus 16. Now, what is inside the square root is minus 16. This is the discriminant. I will call D discriminant equal to minus 16. It is less than 0. Now, if the discriminant is less than 0, I will have two different complex solutions. So square root of minus 16 is minus 6 plus or minus, this is square root of 16 and I for the negative. It is complex. So I square root of 16, all of it divided by 2, or I can write it as minus 6 plus or minus 4i divided by 2. So I have two different or two distinct complex solutions. So either x is equal to minus 6 plus 4i divided by 2, or x equal to minus 6 minus 4i divided by 2. So the solution set in this case, minus 6 divided by 2 is minus 3 plus 2i, 4 divided by 2 is equal to 2, or it is minus 3 minus 2i. So you can see that we have two complex solutions because the discriminant is less than 0. It is a negative number. Let's have another one. I have this equation 2x squared equal to x minus 13. Again, this is a quadratic equation, x to the power 2. But it is not in the standard form. To apply or to use the quadratic formula, we have to write the equation in the standard form, which is 2x squared. Move this to the left-hand side, will be minus 2x plus 13 equal to 0. This must be 0. Now a equal to 2, is the coefficient of x squared. B equal minus 2 and C equal to plus 13. So the quadratic formula x is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a, which is equal to, it is minus 2 is plus 2 plus or minus square root of minus 2 whole square minus 4a is equal to 2 and c equal to 13 divided by 2 times 2. That will give me 2 plus or minus square root of 4 minus 8 times 13. That will be minus 104 divided by 4, which can be written as 2 plus or minus square root of minus 100 divided by 4. So either x will give me 2 plus square root of minus 100, it is I, divided by 4, or negative, it is plus or minus. So I can write it as 2 plus or minus 10i divided by 4. So I'll have two complex solutions. Either x equal to 2 plus 10i divided by 4, or 2 minus 10i divided by 4. So the solution set now can be written as 2 divided by 4 is 1/2 plus 10 divided by 4 is 5 over 2i, or it is 1/2 minus 5 divided by 2i. So these are the two complex solutions, and these are conjugate again. It is a plus and minus. That the two solutions must be conjugate of each other if they are complex numbers. One more example that we have 4x squared plus 12x plus 9 equal to 0. It is in the standard form, so I can write this directly. I have a equal to 4, b equal to 12, and c equal to 9. So the quadratic formula x equal to minus b plus or minus square root of b squared minus 4ac divided by 2a is equal to minus 12 plus or minus 12 square minus 4 times 4 times 9 divided by 2 times 4. This will give me minus 12 plus or minus 144 minus 144 divided by 8, which is equal to minus 12 plus or minus square root of 0 divided by 8. Now the discriminant is equal to 0. What is inside discriminant is equal to 0, which means that we are going to have only one real solution or duplicate real solution. So we'll have x equal to minus 12 over 8. This will be the only solution. That can be simplified, divided by 4, it is minus 3 divided by 2. So the solution set equal to minus 3 over 2. And it is again minus 3 over 2. It is the same solution, or it is the solution or the root with multiplicity 2. It is repeated 2 times. So if the discriminant equal to 0, then we will have only one real solution, and that will be double solution, minus 3 over 2 and minus 3 over 2. If the discriminant is negative, we will have two complex solutions. And if the discriminant is positive, we will have two different real solutions. So this is how to apply the quadratic formula to find the solution of the quadratic equation. But be careful that the quadratic equation must be in the standard form so that we can apply the quadratic formula. Right-hand side must be equal to 0. Then you can apply the quadratic formula.